Hello shipmates, Chris Kreitline here, Celestial Navigation Instructor with Globus Horizon, welcoming you to another video on Celestial Navigation. Have you ever heard of Tristan Jones? He was a sailor. He's passed away already, but he wrote several books. This is probably his most famous book. He did a lot of sailing. He also exaggerated a lot, but if you forgive his exaggerations, his books are pretty good. And I've met several people at various boat shows that knew him personally, and they will attest to the fact that he was quite a character. Anyway, what I want to talk about today, I found this at the back of his book. It's a sight reduction form he used for shooting the sun. And he steps through his sight just the way I teach it, actually. But there's a section right here. It's a graph of some sort. Now, he doesn't use it, but it's interesting. And I've never seen it on a form before like this, only in this particular book and the form that he used for celestial navigation. However, I took it and I put it on the computer and blew it up. And so this video is about this section and how to use it in celestial navigation. It's kind of interesting, and you might find it helpful to use when you're out there blue water and shooting the sun or the moon or the stars. This might help you out. So sit back, relax, and like I said, I'm going to present that graph and how to use it. This is the form out of Tristan Jones's book. I've added a few labels to it for my own purposes to make it a little more user-friendly, but this is essentially it. So what I'd like to do is, first of all, tell you what's the point of this graph. Number two, how it's laid out. And then finally, we'll work an example of how to use it. By the way, if you'd like a copy of this, I don't have it on my website, but if you'd like a copy, send me an email at globizon.com. Sales at globizon.com. That's globizon.com. You know, sales at globizon.com, and I'll send you a copy. Okay. Now, what's the point of this graph? All right. When you're out there on the ocean and you're taking an observation, you will probably end up taking, or at least I have, taken several shots of the same heavenly body over a short period of time. You know, I didn't feel confident in one or the other, so I like to take 3 or 4 shots of the same heavenly body. Now that's, if you're shooting the stars at twilight, that is really difficult. Because they're all going to go dark after a while. You're not going to see, what I mean by that is the horizon is going to go dark and you're not going to be able to get a good shot. But if you're shooting Venus, for example, it shows up right after the sun goes down, and you can take a bunch of shots of it before the horizon goes dark. Or the sun or moon during the day. You can take a whole bunch of shots of the sun in a short period of time. Now, which shot is good? Which is the best of all your observations? If you've got 5 observations of the sun, you know, was there a swell in the way of the horizon? Was the boat rocking? You were off kilter, whatever. So the purpose of this form is to help you graph out your shots and pick the one that is the best to use to put on the form and work up your position. Okay, so what I call this thing is the 3-minute observation plot. So there's room on here to shoot everything you can in 3 minutes. In other words, how many shots of the sun can you take in 3 minutes? And you can put them on here. Now, if you go, there is a way here, and I'll try to show you that when we work an example, where you can do, you can go beyond the 3 minutes and plot past that restriction and still use it to determine your best observation. Right over here on this side, it says altitude minutes. Now that's your HS, your sextant height minutes over here. It starts down here at the bottom, 0, 10, 20, 30, 40, 20, 30, 40, 50, 60, 40, 50, 0, 10, 20. You know, why? Why is it like that? Well, I'll show you later when we work an example how you can use those for your minutes. You're not going to be shooting the degrees. As a general rule, your degrees won't change, but if it does, that's what this one right here is for. The 40, 50, 0, 10, 20. That's so if you change from 1 degree to the next, you use that column. Down here across the bottom, it's set up for 3 minutes. And these are all seconds of your shot. For example, if you take a shot at 10 hours, 55 minutes, and 20 seconds, right here is 20 seconds. Right here is 30 seconds, 40 seconds. Now you go on to the next minute, and you have to move on to this next group of 0, 20, 40, 0, so that would be 60. Then for your third minute, you've got 0, 20, 40, and 60 once again. So it's set up to shoot over 3 minutes of time. Greenwich Mean Time, of course. You don't worry about the hour. The hour will likely not change for you, but if it does, you just move on to the next minute. You can handle that no problem. Here's where you write the minute and second, right here, right here, right here, and then you plot it out on where your shot was. And I'll explain that in a few minutes. So these are up here, these are seconds for each of 3 minutes of time. So what you do is you shoot one body for 3 minutes as often as possible. Then you plot the first shot minutes of altitude from the top of this left scale, continuing down for the subsequent shots. You plot the second of time along the bottom scale for 3 minutes. Then you draw a line connecting. Let's say you've got 3 shots. You plot 1, 2, 3, and then you draw a line with a ruler or your parallel rulers. And those shots should all line up in one line if you did it right. Now, let's say you shot one that was way off. It might be up here. Well, that's obviously a bad shot. Or it may be over here or over there or wherever. So what you're trying to do is draw a diagonal line of best fit. And it says here, reject any outlying shots. Pick the best shot that rests on the slope of that line. That, of course, is the sun either climbing or descending in the sky. Of course, this may go like this. In the morning, if you're shooting the sun or the moon early in the morning, it'll go like that. If you're shooting in the evening, it'll come down like that. So, what you do essentially is this. Let's just take, for example, here's a shot I did of the sun. 1500, I shot 46:32. That was the time of the shot. and I shot 8509. Well, I'll just reveal to you, I was using an artificial horizon here in my driveway. That's why it's so high. Normally, when you're working this, you would divide that by 2, but I'm just plotting this to see which one is best. So let's say 15, 46, 32. Well, 15 I don't worry about. So the time is 46:32. I would write right here 46:32. That's my time in minutes and seconds of my shot. Now my shot was 85 degrees 09. Well, this only wants minutes. So, you know, my minutes are 9. So what I do is, I come over here, 46:32. All right, here's 30, and here's 2, 4, 6, 8, 10. So here's 32 right here. And I can draw a little arrow right there. So that's the time of my shot. And I'm going to go up to 9. Now, which of these do I use? Well, I know it's going to go down. I know it's going to slope that way because it's in the afternoon. So what I've got to do is take my 9 and start up here as high as I can, because the other ones are going to plot here and down here. So here is 0. So I want to go up here to 9 at my arrow. All right. Here is 0 and here is 10. So right there would be 9. Right here. 9 over here for my time. I mean altitude in minutes, I'm sorry. Altitude in minutes is 9. And down here is my time of 32. Here's 30, here's 2. I come up that line to cross over with 9 minutes of altitude. Now obviously if it's 9.5, you do it in the middle. If it's 9.8, you do it real close to the 10. As I tell all my students, celestial navigation is not an exact science, it's an art. So there's a lot of room for extrapolation and fudging everything. But anyway, this is 9, so it would go right there. So that is my first one. Okay? Well, I'm going to go ahead and work a whole problem for you and show you in just a minute. But I think you can understand now. This is for 3 minutes. And this right here is where you find the proper column to mark your minutes. And down here, now this of course is minutes of altitude. Down here is minutes and seconds of time. Okay, so you put your minute and seconds here, go up, cross over, and mark your first site. And then in just a second we'll plot the other 2 and draw a line and see how it all works. All right, I put these instructions on here that were not in the book, but I put these to kind of clue your mind if you don't do it very often. You might want to keep some of these on your boat. Now, when are you going to, like I said, if you're trying to shoot, you know, let's say you're trying to shoot Pollux, a star at night. Well, you're going to have trouble doing 3 different shots of it, because you also want to shoot 2 other heavenly bodies. But let's say that you've got the moon up, and you've got Venus, and you've got Pollux. Well, the moon you can shoot, you know, the last, because it's so bright. Venus you can shoot real early. So maybe you want to take a few extra, you know, 3 minutes to shoot 4 or 5 shots of Pollux that you'll have to be able to plot on here. Then you can turn to shooting the moon on the horizon or Venus, because you're going to be able to see those. But remember, you got to have that horizon, so don't let it get too dark before you move on from Pollux to the moon and Venus. Okay, just some advice on that. All right, now we're gonna move on and do an actual plot of a problem. Now, once again, if you're interested in a copy of this form, this graph, email me at sales@globizon.com, sales@globizon.com, and I'll answer and send you a copy of it. Now here we have shots of the sun taken, let's say in the morning. Here's the Zulu time of the shots, and here are the HSs, the altitudes of the sun. Now here, you know, I'd be shooting the sun to get a line of position in the morning, mid-morning, and then do a running fix with another shot of the sun later on to cross for a position. So here we have the sun. You'll see that 21 minutes, 5 seconds, 21 minutes, 36 seconds, 22 minutes, 10 seconds, 22, 50, 3 minutes worth here of 1, 2, 3, 4, 5 shots. So what we want to do is plot these on this plotting sheet. Now, let's say that this first one is at time 21:05. So that's 5, which would be right here, 5 seconds for the first shot in the 21st minute, and the HS over here is 35:08. So I'm only worried about the 08. So I come up here. First of all, I got to pick which one of these. Well, 8 is you know, close to 0. So I wouldn't use the 20. I wouldn't use the 40 because I got to fit all these in this column here. So I want to go up 8, you know, towards this 10. So that's 5, 6, 7, 8 right here. So this will be the first observation right there. Okay, the next observation is at time 21:36. I'm just going to write this one right here, 21:36. That's 36 seconds. Here's 30, 2, 4, 6. Here's 6 seconds. So I'm going to put that here because this is still 21:36, and the HS is 15, 35:15. So I come up here, here's 10, on up here, right here to 15. So there's my second shot. Now, my third shot is at 22:10. So I'll write 22:10 here, and right here's 10 seconds. And the shot was 35 degrees, 35 minutes. So I want to come up here to 35 minutes. Here's 30 over here. Here's 40, so 35 would be right here. Right here's that shot. Okay, now my next shot is at 22:56. So I'm just going to put it right here, 22:56. Because right here is 52:46 right here. This is 56. It's still 22 minutes. You know, I took 5 shots of the sun as fast as I could. And it's 35:26, so 26 minutes. So I want to go up here. Once again, I look over here for 20. Here's 25, so here's 26. So I got to come over here, 56, and I come up here to 26, which would be right here. So that's my fourth shot. Now here's my fifth shot, 23 at time 23:40. Here's 40, so I can draw my little arrow. And this one is at 31, 35:31. So I go up here, here's 30, and here's 31 right here. All right, so I've got my shots here. Now I've got to draw to see best fit on these things. Well, it looks like to me that's going to be going right up through here somewhere. Right up here. Yeah, I mean, this is once again, this is an art, not a science. But this is the best fit line that goes up here. Best fit line. Oops, it didn't go all the way down here. Okay. Well, what can I see here? Here, these are all going up this slope except this one right here. This thing up here is way out. So I can reject that one. That's not going to do it. And then I look at this best fit line through here. Well, it looks like to me either that shot or that shot would be a good one to use for my line of position. This one, I mean, they're all very close to the slope. But what I definitely don't want to do is pick that one. That's way out. So that's the whole purpose of this thing, is to help you graphically see if you've got some good shots. You may ask, of course, well, what happened here? Why is this thing way out? Well, I don't know, maybe a seagull flew in the way, maybe the boat was heeling over, maybe a tidal wave was passing through, who knows? But definitely want to reject that one and pick one of these others that best fits the slope of the line. Well, this is another tool for the Celestial Navigator to use to try to do the best job he can to eliminate the spurious information and data that you work with and get down to the very best. There's a lot of other things in celestial navigation that can cause you to make mistakes and errors. So every little tool that you've got that can help you eliminate those is beneficial. Of course, I showed you in the book that Tristan Jones didn't use this on that shot anyway. But maybe he did on others. At any rate, I see this most useful when you're shooting the sun and you have the luxury of taking a lot of very quick repetitive shots. Shooting the sun or the moon, like I said, when you've got that luxury. So it's something else to try. And you might want to contact me, send me an email, and I'll be very happy to email you back with a copy of this form that you can try out. If you've got any questions, yeah, you can write me. I'll be happy to answer them and help you out. So, best of luck and fair winds and following seas out there.